Hello there, and welcome to Space Historians. I'm so glad you found your way here tonight. Before we begin our journey together, take a moment to get truly comfortable. Let your weight settle into whatever surface is supporting you right now. There's nowhere else you need to be. Where in the world are you watching from? A quiet bedroom where the day has finally released you? A cozy corner where the sounds of evening are settling into silence? Perhaps you're somewhere under the same stars we'll be contemplating together tonight. Tonight, we're going to explore one of the most profound mysteries in the history of our search for life beyond Earth. On August 15th, 1977, a radio telescope in Ohio detected something that lasted just 72 seconds, but has echoed through nearly 5 decades of scientific inquiry. We'll discover what made this signal so remarkable, understand the human story of its detection, and contemplate what its silence might mean. It's a journey that spans radio astronomy, the mathematics of cosmic probability, and the very nature of our loneliness or connectedness in the universe. But don't worry, this isn't going to be a mystery designed to keep you awake with anxiety or speculation. Instead, we'll move slowly and carefully through the evidence, the theories, and the implications, taking our time with each discovery. We'll examine what we know, acknowledge what we don't, and find a kind of peace in both. By the end, I think you'll find that the story of the wow signal is less about finding answers and more about learning to sit comfortably with profound questions. If you enjoy these calm explorations of cosmic mysteries, a like and subscribe really helps reach others seeking the same peaceful way to end their day. And to those already subscribed, thank you for being here. For trusting these journeys into the unknown. Your presence means more than you might realise, so settle in now. Let your shoulders drop away from your ears. Take a slow breath in through your nose and let it out through your mouth. Feel your jaw relax, and let's begin our slow drift through one of space's most enduring enigmas. There's nowhere you need to be right now, nothing you need to solve. Just listen, and let the story unfold like the universe itself. Vast and patient and beautifully mysterious. The story begins, as so many profound discoveries do, with someone doing work that seemed routine at the time. The night was August 15th, 1977, though the person who would make the discovery didn't witness it in real time. The Big Ear Radio Observatory in Delaware, Ohio, operated differently than you might imagine a telescope works. There were no astronomers peering through eyepieces, no one watching screens in darkened rooms. Instead, the telescope listened, continuously, automatically, recording the whispers of the cosmos onto computer printouts that accumulated in quiet stacks. Waiting to be analysed. Jerry Ehman was a volunteer with the Search for Extraterrestrial Intelligence project. A few days after that August night, he sat down to review the printouts from the telescope's latest observations. This was painstaking work, scanning columns of numbers and letters that represented the intensity of radio signals received from different parts of the sky. Most of the time, the printout showed 1s and 2s, sometimes 3s, representing the normal background noise of space and our own planet. It was like listening to static, looking for a pattern in randomness. But on this particular printout, scanning down the columns in sequence, Ehman's eye caught something that made him stop. There, in the data from August 15th, was a sequence that didn't belong, 6EQ6Q. In the coding system the telescope used, these characters represented signal intensities far beyond anything that should have appeared. The sequence rose from background levels to intensities represented by the letter U. The highest value that could be printed then descended back down in a pattern that looked almost too perfect to be real. The signal had lasted 72 seconds, the exact amount of time the telescope's beam would have taken to sweep across a point source as Earth rotated. Ehman grabbed a red pen. He circled the anomalous sequence and wrote in the margin a single word that would become legendary. Quote, 0. It wasn't a scientific notation. It wasn't protocol. It was simply the honest human response to seeing something that shouldn't exist, something that matched, almost perfectly, what SETI researchers had been hoping to find for years. a signal that appeared to come from beyond our solar system, narrow band and powerful, rising and falling in a way that suggested a source that wasn't moving, that was simply sitting there in space, broadcasting. And this is where our journey truly begins, not with the signal itself, but with that moment of recognition, that instant when a volunteer scientist realized he might be looking at evidence of something extraordinary. Let that image settle for a moment. A quiet room. A printout full of numbers, a red pen, and a word that captured everything wonder and disbelief and hope all at once. Because understanding the wow signal means understanding not just the data, but the humans who found it and what they dared to imagine it might mean. To understand what the Big Ear Radio Observatory detected, we need to understand what it was and how it worked. Imagine, if you will, a structure that doesn't look much like what most people think a telescope should look like. There was no massive dish that could turn and point at different parts of the sky. Instead, the Big Ear was a reflection telescope made largely of metal mesh, stretched across a rectangular framework roughly the size of 3 football fields. It sat in a small Ohio valley, listening to the sky as Earth's rotation slowly swept different portions of the cosmos through its field of view. The design was elegant in its simplicity. Radio waves from space would bounce off this large reflective surface and concentrate at a focal point where receivers waited to catch them. The telescope had 2 feed horns, 2 different receivers that could detect signals from slightly different patches of sky. As Earth turned, these receivers would scan narrow strips of the heavens, like reading lines of text as the page slowly scrolls by. Each point in space would pass through the telescope's beam for approximately 72 seconds, the time it took for Earth's rotation to carry that point across the telescope's field of view. What made the Big Ear particularly suited for searching for extraterrestrial intelligence was its sensitivity and the specific frequency range it monitored. The telescope was tuned to listen around 1420 MHz, a frequency close to what's called the hydrogen line at 1420 MHz. This is significant because hydrogen is the most abundant element in the universe, and many scientists reasoned that any civilization trying to announce its presence might choose to broadcast near this naturally significant frequency. It would be like choosing a meeting place at a landmark everyone knows. A cosmic convention that intelligent beings might independently recognize. The search strategy was based on patience and statistics. The telescope couldn't choose where to look. It simply listened as the sky paraded past. Over time, it would scan the entire visible sky, recording everything, creating a vast database of cosmic radio emissions. Most of what it heard was natural. The hiss of distant galaxies, the crackle of pulsars, the background murmur of the universe itself. Computers would analyze the data looking for anything unusual, anything that stood out against the cosmic background noise. On that night in August 1977, the telescope was doing what it always did, listening, recording, waiting. There was no expectation that this night would be different from any other. The Big Ear had been operating for years, accumulating data, and while it had detected interesting natural phenomena, it had never found what Ehman and others were ultimately hoping for. A clear, unmistakable signal that could only be artificial, that could only be produced by technology, by intelligence, by something or someone trying to communicate across the cosmic void. And yet, on this unremarkable summer night, for 72 seconds, something happened. The telescope received a signal that would puzzle scientists for decades, a signal that still, nearly 50 years later, resists easy explanation. But before we can explore what made this signal so strange, we need to understand exactly what was detected and why it captured the attention of everyone who examined it. The characteristics of the wow signal, when examined closely, create a portrait of something deeply unusual. Let's move through them carefully, understanding why each element mattered and what it suggested. First, there was the signal's intensity. On the printout, the progression read 6EQUJ5. The Big Ear's computer system translated signal strength into numbers and letters, with 1 representing the weakest signals and 10 through Z representing progressively stronger ones. The letter U represented a signal intensity more than 30 times stronger than the typical background noise. This wasn't a subtle anomaly requiring statistical analysis to detect. This was loud, relatively speaking, a clear peak rising from the cosmic static like a mountain from a plain. Second, the signal was narrow band, concentrated in an extremely small range of frequencies. Natural cosmic sources tend to broadcast across a wide spectrum, their energy spread out like light through a prism. But this signal was focused, occupying less than 10 kilohertz of bandwidth. This narrowness is characteristic of artificial transmitters, of technology designed to concentrate energy efficiently at specific frequencies. It's the difference between the roar of wind through trees and a single, pure note played on a flute. Third, the signal appeared to come from a fixed point in space, specifically from the constellation Sagittarius, in a region without any notable stars or known celestial objects. As Earth rotated, the signal intensity rose as that point entered the telescope's beam, peaked when the point was centered, and fell as it exited, following almost exactly the expected pattern for a stationary source. If the source had been on Earth, moving with our planet, the pattern would have been different. If it had been a satellite, the motion would have distorted the rise and fall. This signal behaved like something sitting still in the cosmic reference frame, not moving with Earth or orbiting or following any trajectory we could detect. Fourth, and this is crucial, the signal appeared at a frequency of 1320.456 MHz. This is close to, but not exactly at, the hydrogen line frequency. However, when scientists accounted for Earth's motion through space, they realized the signal might have been transmitted at exactly 1420 MHz in the source's reference frame, with a shift due to the Doppler effect caused by our planet's movement. This suggested the possibility that whoever or whatever was transmitting understood the significance of the hydrogen line and chose it deliberately. But there was a curious asymmetry that troubled researchers. The Big Ear had 2 feed horns, 2 receivers that looked at adjacent patches of sky. A signal from space should have been detected by both, as Earth's rotation carried that point through each receiver's field of view, first one, then the other, about 3 minutes apart. Yet only one feed horn detected the wow signal. The other, which should have seen the same source 3 minutes later, recorded nothing but ordinary background noise. This asymmetry has spawned theories and debates for decades. Was the signal intermittent, broadcasting for less than 3 minutes? Was it a brief pulse that happened to occur only when one receiver was listening? Or was there something else going on? Something about the nature of the source or the detection that we still don't fully understand? The missing second detection is perhaps the single most frustrating aspect of the entire mystery, the detail that keeps the door open to explanations both exotic and mundane. And so we have a signal that was strong, narrow, apparently stationary in space, possibly at a significant frequency, but tantalizingly incomplete. It was enough to be exciting, enough to suggest something remarkable, but not quite enough to be conclusive. It was, in many ways, the perfect mystery, compelling enough to demand attention, but ambiguous enough to resist definitive explanation. This combination has kept scientists returning to it, thinking about it, searching for it, for nearly 5 decades. Once the initial excitement of the discovery settled, the scientific response was exactly what it should have been: verify, replicate, confirm. If the wow signal was truly coming from an extraterrestrial intelligence, it would presumably be detectable again. After all, why would a civilization transmit just once, for just 72 seconds, and then fall silent forever? The logical assumption was that this was either a repeating signal they'd caught one cycle of, or a continuous transmission that should still be ongoing. The big ear immediately began re-observing that same region of the sky. Every time Earth's rotation brought Sagittarius into view, the telescope listened, hoping to catch the signal again. Days passed, then weeks, then months. The telescope heard pulsars, distant galaxies, cosmic noise, but nothing that matched the wow. Signal's distinctive profile, that patch of sky which had briefly shouted so loudly, had returned to its normal whisper of background radiation. Other radio telescopes joined the search. The logic was sound. If one telescope had detected it, others should be able to as well, assuming the signal was still broadcasting. Facilities with more advanced equipment, better sensitivity, and the ability to point precisely at specific coordinates all turned their attention to that region in Sagittarius. They conducted searches not just at the exact frequency of the original detection, but across a range of nearby frequencies, accounting for potential Doppler shifts or frequency drift. They listened for days, weeks, employing strategies that covered different times and dates, thinking perhaps the signal was periodic, transmitted on some schedule they hadn't yet discerned. The result of all these efforts was the same: silence. Wherever the wow signal had originated, it was not broadcasting anymore, or perhaps it had never been a continuous transmission at all. This absence of repetition was itself meaningful. It meant that the signal, whatever its source, was either transient, intermittent on a timescale longer than our observation periods, or perhaps it had been a one-time event, an anomaly that occurred once and would never occur again. This pattern of negative results actually mirrors much of the SETI endeavour. The search for extraterrestrial intelligence is characterised by vast amounts of listening punctuated by brief moments of interest, almost all of which resolve into natural phenomena or human-made interference. The wow. Signal's uniqueness isn't just that it was detected, it's that it has never been conclusively explained away. Most candidate signals can eventually be traced to satellites, radar, military installations, or known natural sources. The wow signal has resisted this kind of resolution for nearly 50 years. Some researchers have maintained regular observations of that region for decades now. There's a hope, perhaps romantic but not unreasonable, that the signal might return. Civilizations could broadcast intermittently, conserving energy or following patterns we don't understand. Or perhaps, if the signal was some natural phenomenon, the conditions that created it might recur. Modern radio telescopes, far more sensitive and sophisticated than the Big Ear was in 1977, keep watch, adding that patch of Sagittarius to their regular observation schedules. But the silence continues, and with each passing year, the silence becomes more difficult to interpret. Is it evidence that the signal was never artificial to begin with? Or is it simply a reminder of how vast space is, how brief and unlikely any moment of contact might be? The search that began in the days after Jerry Ehman circled those 6 characters continues, quieter now, more routine, but no less hopeful. And this persistence itself tells us something about human nature, about our unwillingness to let go of possibilities, about the way a single unexplained event can capture our imagination across generations. In science, when faced with an anomalous observation, the first instinct is to look for natural explanations. Before we invoke anything exotic, we exhaust the ordinary. So let's explore the various natural phenomena that scientists have considered as possible sources of the wow signal, and why each explanation, while plausible in some ways, leaves questions unanswered. The first and most mundane possibility is terrestrial interference. Radio frequency interference from human sources is the bane of radio astronomy. Satellites, radar systems, aircraft, even microwave ovens can produce signals that telescopes might pick up. Could the wow signal have been a brief reflection of a terrestrial transmission, bounced off something and appearing to come from space? The problem with this explanation is the signal's characteristics. It behaved exactly as a stationary cosmic source should, rising and falling in intensity as it passed through the beam, in the precise pattern Earth's rotation would produce. Terrestrial interference typically doesn't follow this pattern so precisely. Additionally, the frequency of the signal didn't match any known transmitters operating in that region at that time. A second possibility involves celestial phenomena we might not fully understand. Space is full of radio sources, pulsars spinning at incredible speeds, magnetars with fields trillions of times stronger than Earth's, regions where matter falls into black holes releasing energy across the spectrum. Could the wow signal have been an unusual burst from a previously unknown natural source? This explanation has appeal because the universe regularly surprises us with phenomena we didn't predict. The first pulsars, when discovered, were briefly considered as potential alien beacons before their natural origin was understood. Perhaps the wow signal was something similar, a natural event we simply haven't characterized yet. However, this explanation faces its own difficulties. The signal's extreme narrowness is hard to explain through natural processes, which typically produce broad-spectrum emissions. Additionally, astronomers have looked for other evidence of unusual activity from that region of space, anything that might suggest an energetic event or exotic object. They found nothing. The region appears utterly ordinary in every other wavelength they've examined: optical, infrared, X-ray. If some violent or unusual process generated the wow signal, we might expect to see evidence of it in other parts of the electromagnetic spectrum, but there's nothing remarkable there at all. A third, more recent theory involves comets. In 2017, a researcher proposed that the wow signal might have been caused by the hydrogen clouds surrounding one or more comets that happened to be passing through that region of sky in 1977. Comets do emit radio waves at frequencies near the hydrogen line as their icy surfaces sublimate in the sun's heat. This explanation has the advantage of accounting for why the signal hasn't repeated. The comet has moved on. Its position in 1977 was coincidentally in the Big Ear's beam, and searchers of that same region wouldn't find it because it's no longer there. But this comet hypothesis has been challenged by other scientists who point out several problems. Comets typically produce much broader signals than what was observed, the calculated intensity of the wow signal seems too strong for a comet emission. And while records from 1977 show some comets were in the general region of the sky, their exact positions at the time of the detection don't perfectly align with where the signal appeared to originate. The debate over this explanation continues, with some finding it satisfactory and others unconvinced. What we're left with is a situation where each natural explanation requires us to accept some uncomfortable coincidences or unproven assumptions. The terrestrial interference explanation requires an almost impossibly perfect mimicry of a cosmic source. The exotic natural phenomenon explanation requires us to postulate something we've never seen before or since. The comet explanation requires us to accept that a relatively ordinary event produced an extraordinarily unusual signal. None of these explanations is impossible, but none is entirely satisfying either. And this brings us to the question that has lingered since that August night in 1977. If natural explanations seem incomplete, what does that leave us to consider? Let's pause here and think about the mathematics of what we're contemplating. When we consider whether the wow signal might have been artificial, we're engaging with probabilities that are difficult for human minds to fully grasp. The universe is so vast and the windows through which we observe it are so small that any contact, even a brief one-time signal, represents an almost miraculous alignment of circumstances. Consider first the vastness of space. The Milky Way galaxy contains somewhere between 100 and 400 billion stars. Many of these stars have planets. Recent observations suggest that rocky, potentially habitable planets might be extraordinarily common. But habitable doesn't mean inhabited. We don't know what fraction of habitable planets actually develop life, and we don't know what fraction of those that develop life go on to develop intelligent technological civilizations. These unknowns compound. making any estimate of how many civilizations might exist incredibly uncertain. Now layer on top of this the dimension of time. The universe is about 13.8 billion years old. Our galaxy is nearly as old. Civilizations might arise, flourish, and vanish across timescales of millions of years, mere moments in cosmic terms. For two civilizations to exist simultaneously is one level of coincidence. For them to both be at a technological stage where they can transmit and receive radio signals is another. For one to decide to transmit and the other to be listening at the right frequency at the right time is yet another layer of improbability. The Big Ear Radio Observatory, during its operational lifetime, scanned the sky repeatedly, but could only observe a small fraction of it at any given moment. On that August night in 1977, it happened to be looking at one particular patch of Sagittarius. If a signal had been transmitted from a different direction, or at a different time, or at a slightly different frequency, the Big Ear would never have detected it. The telescope's bandwidth, the frequencies it could monitor simultaneously, was limited. Space broadcasts across an infinite range of possible frequencies. We happened to be listening at roughly 1420 megahertz, but a civilization might choose to transmit at any frequency across the electromagnetic spectrum. When you multiply all these factors together, the probability of detecting even a single transmission from another civilization, even if such civilizations are relatively common, becomes vanishingly small. It would be like standing on a beach, closing your eyes, spinning around, and opening them at precisely the right moment to see a specific grain of sand being struck by a specific photon of light from a specific star. The improbability is almost paralyzing. And yet, paradoxically, this extreme improbability doesn't mean detection is impossible. In a universe vast enough, even extraordinarily unlikely events must occasionally occur. Someone wins the lottery, despite odds of millions to 1 against. The Big Ear listened for years, sampling billions of potential transmission windows. Was 1977 simply the moment when our observation window happened to align with a brief transmission from elsewhere? The mathematics can't tell us this didn't happen. They can only tell us how remarkable it would be if it did. This is the knife edge we walk when evaluating the wow signal. If we calculate the prior probability of an alien civilization transmitting at exactly the right frequency, at exactly the right time, in exactly the direction we happen to be looking, it seems almost impossible. But if we consider that billions of observations have been made across decades of SETI work, and only one has produced a signal this compelling and unexplained, perhaps the improbability isn't quite as crushing as it first appears. What the mathematics really teaches us is humility. We can't calculate our way to certainty in either direction. The numbers are too uncertain, the unknowns too profound. What we're left with is the data itself, a strong, narrow-band signal that appeared once and never repeated, that matches some expectations for what an artificial signal might look like, but that could possibly have a natural explanation we haven't fully considered. The mathematics of contact reminds us that we're searching in an almost infinite haystack for a needle that might not exist, and that finding even a hint of one is, whether artificial or natural, remarkable in its own right. If we entertain, even as a thought experiment, the possibility that the wow signal was artificial, it raises fascinating questions about communication across cosmic distances. How would a civilization attempt to announce its presence? What strategies might they employ, and what can the characteristics of the signal tell us about the possible intentions or capabilities of its source? The concept of a beacon transmission is central to much SETI theory. Rather than trying to send complex messages immediately, a civilization might first simply announce, "We are here." A beacon would be designed to be unmistakable, to stand out against the natural background of cosmic radio emissions. It would be strong, focused, and probably at a significant frequency that other technological species might think to monitor. The wow signal with its intensity and narrowness, fits this profile reasonably well. It was loud enough to be detected across interstellar distances. It was concentrated enough to look artificial, and it was near a frequency that many SETI researchers consider a logical place to listen. But if it was a beacon, why broadcast only once, or at least only so briefly? There are several possible answers, none entirely satisfying. Perhaps the transmission is actually continuous or regularly repeating, but our observations have been too sparse or poorly timed to catch it again. Imagine a lighthouse that sweeps its beam in a circle. If you only look for a brief moment in a direction the beam isn't currently pointing, you'll see nothing. Perhaps the wow. Signal was our one glimpse of a beam that hasn't swept back to us in the decades since. Or perhaps the transmission was genuinely brief, a kind of cosmic announcement that runs for a while and then stops, the civilization moving on to other projects or other methods of communication. If you were trying to announce your presence to any listening civilizations in your galactic neighborhood, you might transmit for years or centuries, long enough to give anyone who might be listening a reasonable chance to detect you, but not forever. From our perspective, catching such a transmission would be pure luck, happening to have our telescopes pointed in the right direction during the active transmission period. There's another, more sobering possibility. Perhaps the signal was one time not by choice but by circumstance. Civilizations might rise and fall. Technologies might be built and then abandoned or destroyed. If we detected a transmission from a civilization in its brief window of technological radio broadcasting, before they moved on to other communication methods, or before some catastrophe befell them, we might never detect them again. This interpretation fills the wow signal with a kind of melancholy, a voice calling out in the dark, preserved in our data, but the speaker long since silent. The content of the signal, unfortunately, tells us almost nothing beyond its existence. With only 72 seconds of data and no complex modulation that anyone has been able to detect, there's no message to decode, no information to extract beyond the signal's basic properties. It's as if we received a knock on a door, but no one answered when we opened it. The knock is real, we have evidence of it, but we don't know who knocked, why they knocked, or where they went afterward. This brings us to a profound asymmetry in cosmic communication. We imagine civilization sending out messages full of information, prime numbers, images, greetings, invitations. But the reality might be far simpler and more frustrating. The first detection, if we ever make one, might be nothing more than a carrier wave, a tone, a ping that says only something technological exists without telling us anything more. And if that signal doesn't repeat or isn't caught by multiple observatories, we're left in exactly the position we're in with the wow. Signal, tantalizing evidence of something, but not enough to build understanding upon. Still, there's something profound in the attempt itself, whether the signal was artificial or natural. Somewhere in the data we've collected, in that sequence of numbers and letters that Jerry Ehman circled in red pen, is either a message from across the stars or a reminder of how strange the universe can be. Either possibility, when you sit with it long enough, fills the mind with a kind of quiet wonder. The absence of the wow signal in subsequent observations is in many ways as important as its initial detection. Silence in this context carries meaning, though the interpretation of that meaning depends on assumptions we can't verify. Let's explore what this enduring silence might tell us, and what questions it raises about the nature of the original signal. In the months and years following August 1977, as mentioned, the Big Ear continued to monitor that same region of sky whenever Earth's rotation brought it into view. The telescope's routine was methodical, systematic, patient. Over hundreds of observation periods, it listened to that exact spot in Sagittarius, hoping to catch the signal again. The hours of observation added up, dozens, then hundreds, then thousands. Each session lasted until Earth's rotation carried that region out of view. Each time, the result was the same. Background noise, the normal whisper of cosmic radiation, but no repeat of that extraordinary spike in signal strength. This consistency of absence is scientifically significant. It tells us that whatever produced the wow signal, it wasn't a continuously transmitting source in that location. If a radio beacon had been permanently stationed there, broadcasting steadily like a lighthouse, we would have detected it again and again. The fact that we didn't means the signal was either transient, intermittent on a timescale longer than our observation period, or came from something that was moving through that region of space rather than fixed there. Modern follow-up observations have employed vastly superior technology compared to what was available in the 1970s. The Big Ear, impressive as it was limited by the technology of its era. Today's radio telescopes have far greater sensitivity, can scan wider bandwidth simultaneously, and can observe with precision that would have seemed impossible 50 years ago. These modern instruments have looked at that region repeatedly. They've searched not just at the exact frequency of the original detection, but across a broad range, accounting for any possible Doppler shifting or frequency drift that might occur if the source was moving, or if our calculations of the original frequency were slightly off. The result of all this technological advancement and dedicated searching is the same profound silence. If anything, the silence has become more definitive, more comprehensive, more difficult to attribute to our missing something that's actually there. We've looked so thoroughly, so carefully, with such sensitive instruments, that we can say with increasing confidence there is nothing broadcasting from that region now that resembles the wow signal. Some researchers have considered whether the silence might be informative in a different way. Could the absence of repetition actually tell us something about the nature of the source? If the signal was artificial, perhaps it was a directed transmission aimed somewhere else. A beam that happened to sweep across Earth for just those 72 seconds as it scanned space. Like catching a glimpse of a searchlight beam that quickly moves on, never to return. This interpretation would explain both why we detected it and why it never repeated. We were never the intended audience. Just accidental eavesdroppers on a conversation meant for someone else. Or perhaps the silence reflects something more fundamental about cosmic communication. If civilizations are rare and separated by vast distances, and if they broadcast intermittently rather than continuously, the probability of any given observation catching a signal is extraordinarily low. The wow signal might have been our one lucky moment in decades of searching. A cosmic jackpot that we happen to hit once but will never hit again, at least not at that same spot in the sky. There's a strange comfort in accepting the silence. It means the universe remains mysterious, that it hasn't given up all its secrets, that there are still profound questions without easy answers. The silence following the wow signal has lasted nearly 50 years now, longer than many scientific careers, longer than some of the people who first analysed it have been alive. And yet that silence hasn't diminished the signal's significance. If anything, it has enhanced it, turning a 72-second detection into an enduring enigma that continues to inspire wonder and careful thought. The wow signal wasn't the first candidate SETI signal, and it hasn't been the last. Placing it in context with other detections helps us understand both what made it special and what it shares with other moments of hope and disappointment in the search for extraterrestrial intelligence. Before the wow signal, there were intriguing moments that seemed promising but ultimately resolved into natural phenomena or human-made sources. The first pulsars, discovered in 1967 by Jocelyn Bell Burnell, were briefly considered as possible artificial beacons. Their incredibly regular pulses, repeating with timing more precise than the best atomic clocks, seemed almost too perfect to be natural. The Discovery team even jokingly called them LGSM signals. Little green men. But further observations showed that pulsars were a natural consequence of rotating neutron stars. Their emissions beamed like cosmic lighthouses as they spun. The mystery was solved, the natural explanation confirmed, and astronomy gained understanding of a new type of stellar object. After the WOW signal, there have been other candidates that generated excitement. In 2003, a signal designated SHGB 02+14a was detected by the SETI at Home project, which distributed radio telescope data to millions of home computers for analysis. This signal was detected multiple times, which initially seemed more promising than the one-time WOW signal. But the detections were inconsistent, and eventually the signal was traced to a source that moved in ways inconsistent with a cosmic origin. Most likely, it was some form of terrestrial interference or satellite transmission that happened to appear to come from deep space due to the complex way radio signals can bounce and reflect. More recently, in 2019, there was excitement about a signal called BLC1, detected by the Breakthrough Listen project using the Parkes telescope in Australia. This signal was narrow band, appeared to come from the direction of Proxima Centauri, our nearest stellar neighbour, and showed a slight frequency drift consistent with motion. For a brief time, it seemed like possibly the most promising candidate since the WOW signal. But further investigation revealed it was almost certainly due to interference from human-generated radio frequency sources, probably electronics associated with the telescope facility itself. The signal disappeared when the telescope was pointed away from Proxima Centauri and reappeared when pointed back, which might initially seem to confirm an extraterrestrial origin, but the specific characteristics of how it behaved eventually pointed to a more mundane, terrestrial explanation. What distinguishes the WOW signal from these other candidates is primarily the thoroughness with which natural and human-made explanations have been explored and found wanting. With most candidate signals, as more data is gathered and more analysis is done, the natural or terrestrial explanation becomes increasingly clear. But with the WOW signal, the opposite has happened. The more we've looked at it, the more we've thought about it, the more mysterious it has remained. We can propose explanations, but we can't confirm them definitively. This pattern teaches us something about the nature of the SETI endeavour. Most detections, even exciting ones, eventually resolve. The universe is full of radio sources, and Earth is full of radio transmitters, and separating cosmic signals from terrestrial interference is extraordinarily challenging. The fact that we have even one signal that has resisted definitive explanation for nearly 50 years is, in itself, remarkable. It suggests that whatever the WOW signal was, it represented something genuinely unusual, something at the edges of our understanding or our observational capabilities. The history of candidate signals also reveals the evolution of our searching capabilities and our understanding. Each new detection, even those that turn out to be false alarms, teaches us something about what to look for, what might mislead us, and how to design better searches. The techniques developed to analyse the WOW signal have been refined and applied to subsequent observations. The lessons learned from SHGB 02+14a and BLC1 have made us better at identifying terrestrial interference. In this way, even the disappointments contribute to progress, each investigation adding to our collective knowledge of how to search the cosmos for signs of intelligence. And perhaps this is the appropriate frame for understanding the WOW signal among all these other candidates, not as a definitive answer, but as the most compelling question we've encountered so far in our cosmic search. The one case where the usual methods of elimination haven't given us a clear, satisfying conclusion. Let's turn our attention now to the specific region of space where the WOW signal appeared to originate. Understanding what we know and don't know about this patch of sky adds another dimension to the mystery and helps us think about what might or might not have been there. The signal's apparent origin was in the constellation Sagittarius, at celestial coordinates approximately right ascension, 19 hours 25 minutes, and declination negative 26 degrees 57 minutes. For those unfamiliar with celestial coordinates, think of this as an address in the sky, a specific direction we can point telescopes toward. Sagittarius is a rich area of the night sky, located in the direction of our galaxy's centre. When we look towards Sagittarius, we're looking through the dense star fields of the Milky Way's spiral arms and toward the supermassive black hole that sits at the galaxy's heart. But the specific location of the WOW signal wasn't aimed at any particular notable object. There are no bright stars at that exact position, no known galaxies, no nebulae or star clusters that might be emitting unusual radio waves. Astronomers have examined this region in multiple wavelengths: optical, infrared, X-ray, radio. They've found ordinary background stars, some so distant and faint they can barely be seen even with powerful telescopes, but nothing that stands out as unusual or that could obviously be the source of a strong narrow-band radio signal. This ordinariness is, in some ways, as puzzling as the signal itself. If a natural phenomenon produced the WOW signal, we might expect to see other evidence of unusual activity in that region. Active galactic nuclei. Regions where matter is falling into black holes produce radio emissions, but they also produce emissions in other wavelengths. Supernova remnants glow in radio and X-rays. Regions of active star formation light up in infrared. But that patch of Sagittarius appears quiet and unremarkable in every way except for that one 72-second burst of radio energy detected nearly 50 years ago. The uncertainty in the signal's exact origin adds another layer of complexity. The Big Ear's beam was relatively wide by modern standards. When we say the signal came from a specific position in Sagittarius, we mean it came from somewhere within a region several times the apparent size of the full moon. There could be hundreds of faint stars within that area. If we're looking for an explanation, we can't examine one specific object. We have to consider everything in that general region of sky. There's also the question of distance. The signal's characteristics don't tell us how far away its source was. It could have originated from something relatively nearby in cosmic terms, perhaps within our own galaxy, or it could have come from much farther away, from another galaxy entirely. Radio waves can travel across intergalactic space, diminishing in strength but remaining detectable if the source is powerful enough and the receiver sensitive enough. The WOW signal's intensity suggests it was either relatively close and moderately powerful, or very distant and incredibly powerful. Without more information, we can't distinguish between these possibilities. Modern surveys of the sky have catalogued the positions and properties of billions of stars and galaxies. Astronomers have gone back to the region of the WOW signal and identified every object we can detect there with current technology. None of them are obviously special. None of them stand out as the kind of source that might produce such a signal. This doesn't prove there's nothing there, of course. It just means that whatever the source was, if it still exists, it's either too faint to detect in other wavelengths, or it's not producing other types of emissions that our telescopes can pick up. There's something almost poetic about this absence of obvious targets. The signal points to a region of sky that seems, by all accounts, ordinary. A random patch of stars and dust and darkness, no different from countless other patches scattered across the celestial sphere. And yet, for 72 seconds on a night in August 1977, something there spoke, or seemed to speak, or made itself known in a way that has echoed through decades of subsequent observation and thought. The unremarkable location somehow makes the signal more remarkable, more mysterious, more difficult to explain or dismiss. It's as if the universe chose the most unexpected place to leave its most compelling puzzle. Let's return for a moment to Jerry Ehman himself, the man who wrote quote 5 in the margin of that computer printout, because his story helps us understand how science actually works, and how discoveries happen not through grand proclamations but through careful attention and honest reactions to unexpected data. Jerry Ehman was a professor at Franklin University in Columbus, Ohio, teaching computer science. His involvement with the Big Ear Radio Observatory was as a volunteer, driven not by professional obligation but by genuine curiosity about the cosmos and the possibility of finding evidence of intelligence beyond Earth. This is important to understand. Ehman wasn't under pressure to make a discovery. He wasn't seeking fame or funding or career advancement through his work analysing radio telescope data. He was simply someone who found the question fascinating and was willing to donate his time to help search for answers. The work of reviewing printouts was tedious. Imagine sitting with pages and pages of numbers and letters, most of which represent nothing but background noise, looking for patterns that almost never appear. It required patience, attention to detail, and the ability to recognise when something didn't fit the expected patterns. Most volunteers would review their assigned printouts, find nothing unusual, and move on to the next batch. This was the norm, the expected result of the work. When Ehman saw that sequence, 6EQUJ5, his immediate recognition of its significance came from understanding what those characters meant and what they implied. He knew the coding system. He knew that U represented the maximum printable intensity. He could see, immediately, that the signal had the characteristic rise and fall pattern of a point source passing through the telescope's beam. And he understood the implications. This was exactly what a signal from space should look like. His quote 6 wasn't a scientific conclusion. It was an exclamation of surprise and wonder, the honest human reaction to seeing something extraordinary. In interviews over the years, Ehman has been careful to note that he never claimed the signal was definitely extraterrestrial. He has remained, throughout his life, appropriately cautious about interpretation. He found something anomalous. He recognised its potential significance. He circled it and brought it to the attention of others. This is exemplary scientific practice. Observe, document, report, but don't jump to conclusions beyond what the data can support. Over the decades since, Ehman has given numerous interviews and written about the signal. He's expressed frustration that it hasn't been detected again, which would resolve the mystery one way or another. He's acknowledged the various natural explanations that have been proposed, considering each on its merits. He's never claimed certainty about what the signal was, but he's also never wavered from his initial assessment that it was genuinely unusual, worth investigating, worth thinking about. There's something deeply human and relatable about Ehman's role in this story. He was in the right place at the right time, doing work that most people would find dull, and he was paying enough attention to recognise when something remarkable appeared. We can all aspire to that kind of attentiveness, that readiness to notice when the patterns break, when something unexpected occurs. His red pen circling those 6 characters became a kind of icon for SETI, a symbol of the moment when careful observation meets cosmic mystery. Ehman's continued involvement with discussions about the signal, his willingness to engage with new theories and new data, his combination of openness and skepticism, represents the best of scientific thinking. He's hopeful that we might someday understand what he found, but he's not attached to any particular explanation. He wants the truth, whatever it turns out to be, and he's contributed to the search for that truth by being honest about both what he knows and what he doesn't. And that red pen, that simple quote, 7, written in the margin of a printout that might otherwise have been discarded or filed away and forgotten, became the name by which the signal is known worldwide. It's a reminder that science is done by humans, that discovery often begins with surprise and wonder, and that sometimes the most profound questions emerge from the most unexpected moments. The response of the broader SETI community to the WOW signal reveals much about how scientists handle potentially revolutionary but ambiguous data. This wasn't a case of unified certainty or dismissal, but rather a spectrum of reactions that reflected different philosophies about evidence, explanation, and the extraordinary claims requiring extraordinary proof. Some researchers saw the WOW signal as exactly the kind of detection SETI had been searching for. It had the right characteristics: narrow band, strong, apparently from space, at a significant frequency. For those inclined to believe that technological civilizations might be relatively common in the universe, The signal was encouragement to continue searching, evidence that the methodology was sound even if this particular detection couldn't be confirmed. They argued that if signals like this exist, even rarely, then patient systematic searching would eventually find more of them. Others in the SETI community were more cautious. They noted correctly that a single non-repeating detection, however intriguing, couldn't constitute proof of extraterrestrial intelligence. Science requires reproducibility. Extraordinary claims do indeed require extraordinary evidence. Without confirmation, without understanding the source, without ruling out all natural explanations, the signal remained an anomaly. Interesting, but not conclusive. These researchers advocated for continued searching while maintaining appropriate skepticism about interpretation. There were also those who focused on the methodological implications. The fact that the Big Ear had operated for years without finding anything similar suggested that signals like this, if they exist, are extraordinarily rare. This raised questions about search strategy. Should CTI focus on surveying large portions of the sky briefly, hoping to catch transient signals, or should it observe specific promising targets repeatedly for long periods, hoping to catch repeating transmissions? The wow. Signal's characteristics, one time but strong, didn't clearly favour either approach. The signal also influenced the design of subsequent SETI projects. Some facilities implemented protocols for immediate follow-up. If something interesting was detected, other telescopes would be alerted quickly to observe the same region of sky before a transient signal could fade. This rapid response approach was partly motivated by the frustration of the wow signal. By the time it was noticed on the printout, days had passed, and the opportunity for immediate confirmation was lost. Modern SETI projects process data in near real time specifically to avoid this kind of delayed discovery. There was also discussion about whether the wow signal should influence where we search. Some argued that the fact that it appeared to come from an unremarkable region of Sagittarius suggested we should survey the entire sky more thoroughly, rather than focusing only on nearby sun-like stars or other obvious targets. If signals can come from anywhere, then everywhere deserves equal attention. Others countered that the single detection didn't provide enough information to change fundamental search strategies. It might have been a fluke, and focusing on the most promising stellar systems remained the most efficient approach. The ongoing debate about the wow signal has also served an educational function within the SETI community. Each new generation of researchers learns about it, analyses it, considers what it might mean. It's become a kind of case study in how to think about ambiguous evidence. What level of certainty is required before we announce a detection? How do we balance skepticism with openness to possibilities? How do we maintain scientific rigour while searching for something we've never seen before? These are fundamental questions for SETI, and the wow signal provides a concrete example around which to frame discussions. Perhaps most significantly, the signal has kept the search alive in the public imagination and in funding conversations. SETI has always struggled for resources, competing against other scientific priorities that have more predictable returns. But the wow signal serves as a reminder that the search might actually find something, that there are genuine mysteries to investigate, that the question of whether we're alone in the universe remains open and worthy of serious scientific attention. And so, the SETI community's response to the wow signal has been appropriately complex and multifaceted. It's neither been dismissed as obviously natural nor celebrated as proof of alien intelligence. Instead, it's been treated as what it is: compelling evidence of something unusual that demands explanation, but defies easy categorization. This measured, thoughtful approach is exactly what we should hope for from scientists confronting the unknown. Beyond the scientific community, the wow signal has captured the public imagination in ways that reveal our deep longing for contact, our hope that we might not be alone in the universe, and our tendency to find meaning in mysteries. The signal has become part of popular culture, referenced in films, books, music, and countless online discussions, often simplified or sensationalized in ways that depart from the scientific reality. In popular retellings, the wow signal is often presented as an alien message that we received but couldn't decode, or as definitive proof of extraterrestrial intelligence that mainstream science refuses to acknowledge. These narratives are more compelling than the truth, which is that we don't know what it was and may never know. But human psychology craves resolution, answers, clear interpretations. Ambiguity is uncomfortable. So the story gets shaped into something more definitive, something that satisfies our need for meaning. The internet age has amplified this process. Forums and social media platforms are full of discussions about the wow signal, with theories ranging from plausible to wildly speculative. Some claim it was a message from a specific star system, though we don't know the distance to the source. Others weave it into broader narratives about government cover-ups or secret knowledge. The signal becomes a kind of cosmic Rorschach test, onto which people project their beliefs about aliens, about authority, about the universe and our place in it. Documentary films and television programs have featured the wow signal prominently. These presentations often emphasize the mystery and the tantalizing possibility of alien contact, sometimes at the expense of accurately representing the uncertainties and the various natural explanations that remain possible. The dramatic potential is obvious. Scientists searching for extraterrestrial life, a brief moment of apparent contact, and then decades of unanswered questions. It's a narrative structure that storytelling naturally favours, even if it oversimplifies or sensationalizes the actual science. Musicians have referenced the signal in lyrics and album titles. Artists have created visualizations of it. The sequence 6EQUJ5 has become iconic, recognizable to people who follow space science or SETI, a cultural touchstone representing humanity's search for cosmic companions. There's something appealing about the idea that somewhere in our accumulated data, in our archives of observations, might be hidden a message from the stars if only we could recognize it. But this public fascination, while sometimes frustrating to scientists who want to maintain appropriate skepticism, also serves valuable purposes. It keeps interest in SETI alive. It funds research through public support and donations. It inspires young people to study astronomy and radio engineering. The wow signal, even misunderstood or oversimplified, points people toward the genuine questions. Are we alone? How would we know if we aren't? What would contact mean? These are profound questions worth asking, worth exploring, even if the wow signal itself doesn't provide answers. There's also something democratizing about the wow signal's place in public consciousness. You don't need advanced degrees to understand the basic story. A telescope detected something unusual that hasn't been seen again. The mystery is accessible. Anyone can think about it, form opinions, imagine possibilities. In this way, the signal has become a kind of common property of human imagination, a shared mystery that transcends professional boundaries and national identities. The challenge, of course, is maintaining a connection between public fascination and scientific accuracy. When the narrative becomes too simplified or when speculation is presented as fact, it can undermine the actual search for truth. Scientists working on SETI have to balance their communication with the public, encouraging interest and support while also explaining the uncertainties, the need for rigorous investigation, and the importance of not jumping to conclusions. Yet even with all the mythology that's grown up around it, the core reality of the wow signal remains compelling without embellishment. The facts alone are remarkable. A strong, narrow-band signal, detected once, never repeated, unexplained for nearly 50 years. We don't need to claim it was definitely aliens or definitely a message to find it fascinating. The genuine mystery is enough. And perhaps that's the real lesson of the public response to the wow signal, that humanity is hungry for mystery, for the possibility of contact, for evidence that the universe might be more wondrous than we dare to hope. Whether the signal was artificial or natural, it touches something deep in human consciousness, a longing to know we're not alone in the vast darkness between the stars, behind the science and the speculation about the wow. Signal lies a more practical question. What does it cost to search for evidence of extraterrestrial intelligence, and is that cost justified? These questions have shaped SETI's history and continue to influence how the search is conducted and what resources are devoted to it. The Big Ear Radio Observatory operated on remarkably modest budgets, especially compared to other astronomical facilities. Much of the work was done by volunteers like Jerry Ehman. The telescope itself was built partially with surplus military equipment. This scrappy, underfunded approach characterised much of SETI's early history. The search was driven more by passion and curiosity than by institutional support or abundant resources. In the 1990s, NASA initiated a more comprehensive SETI program with significant funding, planning to conduct systematic searches across the sky. But in 1993, just 1 year after it began, Congress cancelled the program. The criticism was direct. This was a search for little green men, and taxpayer money shouldn't be spent on something so speculative, so unlikely to produce results. The cancellation forced SETI research to become primarily privately funded, dependent on donations from individuals and organisations willing to support the search without government backing. This funding challenge shapes everything about modern SETI. Without large budgets, telescope time is limited. Data analysis relies partly on distributed computing projects where volunteers donate their computer's processing power. The number of researchers who can dedicate their careers to SETI is small. Every decision about where to search, what frequencies to monitor, how long to observe particular targets is constrained by resources. The search is driven by passion, but limited by practicality. Yet the cost of SETI, even at its most ambitious, is tiny compared to many other scientific endeavours or compared to countless other ways society spends money. A single military weapons system often costs more than the entire history of SETI funding combined. Major particle physics experiments or space telescope missions dwarf SETI's budget. In perspective, humanity spends an almost negligible amount searching for evidence of other intelligent life in the universe. Is this appropriate? The argument for SETI funding is that the potential payoff, while unlikely, would be revolutionary. Confirming that we're not alone in the universe, making contact with another civilization, would be among the most significant discoveries in human history. It would reshape our understanding of life, intelligence, and our place in the cosmos. Even a small probability of such a momentous outcome might justify modest investment, especially when the cost is so low. The counter-argument acknowledges this possibility, but questions whether SETI is the best use of limited scientific resources. There are known problems that demand attention: climate change, disease, energy production, fundamental physics questions. Should we divert resources to searching for something that might not exist when there are definite problems requiring solutions? This debate reflects deeper questions about priorities, about how we value different kinds of knowledge, about whether searching for truth in unlikely places is worth the cost when there's guaranteed work to be done elsewhere. The wow signal sits at the heart of this funding debate. For advocates of SETI, it's evidence that the search can find something, that there are genuine anomalies worth investigating, that the methodology is sound even if results are rare. For skeptics, it's a reminder that even the best candidate in 50 years of searching hasn't provided definitive answers, hasn't changed our understanding, hasn't justified the time and money spent. Both interpretations have validity. Modern SETI has adapted to funding constraints through clever strategies. Projects like SETI at home use volunteers' computers to analyse data, distributing the computational cost. Breakthrough. Listen, funded by private donors, has brought new resources to the field. Some SETI searches piggyback on observations conducted for other astronomical purposes, adding minimal cost by analysing data that would be collected anyway. These approaches allow the search to continue even without large-scale institutional funding. There's also an argument that SETI's value extends beyond detection. The techniques developed for searching for artificial signals have applications in regular astronomy. The data collected has scientific value for studying natural radio sources even if no aliens are found. The search inspires technological development, education, and public interest in science. These secondary benefits might justify the cost independent of whether we ever detect an extraterrestrial signal, and so the search continues, underfunded but persistent, driven by the question, the wow, signal embodies, might there be something out there worth finding? The cost is real, but in the grand scheme of human expenditure it's modest. Whether that modest investment will ever yield returns as significant as confirming we're not alone remains, like so much about the wow signal itself, an open question. Perhaps the most valuable lesson the wow signal offers isn't about aliens or radio astronomy, but about how we live with uncertainty, how we hold space for questions that may never be answered, and what intellectual humility requires of us when confronting the unknown. In our daily lives, uncertainty is often uncomfortable. We want answers, conclusions, resolutions. When faced with ambiguous situations, we feel pressure to decide, to choose an interpretation, to settle on an explanation even if the evidence doesn't fully support it. The wow signal resists this pressure. Nearly 50 years have passed, countless expert hours have been devoted to analysing it, and the honest answer to quote 8, quote 9 remains quote 9. This sustained uncertainty is, in its own way, valuable. It reminds us that the universe doesn't owe us answers on our timeline. Some questions may remain open for generations. Some mysteries might never be solved. And this is okay. It's appropriate. It reflects the actual limits of human knowledge and observation, rather than our wish for certainty and closure. The various scientists who've studied the wow signal demonstrate different ways of holding this uncertainty. Some lean toward natural explanations, finding the combination of characteristics more likely to result from some unusual but mundane phenomenon we haven't fully understood. Others lean toward the possibility of an artificial source, noting how well the signal matches predictions for what an extraterrestrial transmission might look like. But the most thoughtful researchers acknowledge that they're leaning, not concluding. They hold their interpretations lightly, ready to revise them if new evidence emerges. This intellectual humility, this willingness to say, "I don't know," and mean it genuinely, is increasingly rare and valuable. In public discourse, on social media, in political debate, certainty is rewarded. Admitting uncertainty is often seen as weakness, as lack of expertise, as failure. But in science, and perhaps in life more broadly, the ability to remain uncertain while still engaging thoughtfully with questions is a strength, not a weakness. It's the opposite of dogmatism, the opposite of closing one's mind prematurely. The wow signal also teaches us about the nature of evidence and what it can and cannot tell us. We have data, a strong, narrow band signal detected once and never again. This data is real, reliable, well documented. But data alone doesn't interpret itself. The same evidence can support multiple hypotheses, each with different prior probabilities and different implications. Learning to sit with this ambiguity, to understand that evidence can be genuine without being conclusive, is a crucial skill for navigating a complex world. There's also value in learning to distinguish between different kinds of uncertainty. We're uncertain about what caused the wow signal, but we're quite certain about what was detected. The signal's characteristics are well documented and not in dispute. We're uncertain about whether extraterrestrial civilizations exist, but we're certain about the mathematics that govern how we might detect them if they do. sorting through these layers of certainty and uncertainty, understanding what we know and how we know it versus what we don't know and why we don't, is essential for clear thinking. The ongoing search for an explanation, the refusal to simply accept quote 11 quote as a final answer while also not forcing premature conclusions, demonstrates a healthy relationship with uncertainty. Researchers continue to propose new theories, analyze the data with new techniques, search for similar signals. This active engagement with an unsolved problem is intellectually honest. It says, we don't know yet. But we haven't stopped trying to find out. This is science at its best. For those of us who aren't professional astronomers or SETI researchers, the wow signal offers a kind of permission to be uncertain about big questions while still finding them meaningful. We don't have to choose between dismissing mysteries as unsolved and therefore unimportant, or claiming to have answers we don't actually have. We can hold the question open, engage with it thoughtfully, appreciate what we do know while acknowledging what we don't. And perhaps this is the signal's greatest gift to us. Not an answer about whether we're alone in the universe, but a demonstration that we can live with profound questions, that we can be comfortable with uncertainty, that we can continue searching and thinking and wondering without needing immediate resolution. In a world that often demands quick answers and confident assertions, the wow signal invites us to pause, to consider, to admit that some things remain mysterious despite our best efforts to understand them. And there's a kind of peace in that admission. A recognition that the universe is vast and strange and doesn't exist to satisfy our need for certainty. To truly understand what the wow signal might mean, we need to step back and consider Earth's place in the cosmos, the moment in time we occupy, and the particular window through which we're searching for signs of other intelligence. Our perspective is limited in ways both obvious and subtle, and recognizing these limitations helps us think more clearly about what we might find or might miss. Earth orbits an ordinary star, one of perhaps 400 billion in our galaxy alone. The Sun is neither particularly large nor small, neither especially hot nor cool, neither young nor old. It sits roughly 2/3 of the way out from the galaxy's centre, in a relatively quiet region of one of the spiral arms. This ordinariness is, in some ways, reassuring. If life arose here, around this unexceptional star, perhaps it's common elsewhere around similar stars, but our ordinariness also means we're just one tiny vantage point among countless billions, seeing a narrow slice of cosmic phenomena. We're also living at a specific moment in cosmic history. The universe is about 13.8 billion years old. Our Sun and Earth are about 4.5 billion years old. Civilization, in the sense of organised agriculture and cities, is maybe 10,000 years old. Radio technology is barely a century old. We're newcomers on a cosmic timescale, infants really. And we're searching for signals from others who might be at any point in their own developmental timeline. This temporal positioning matters profoundly. If civilizations typically last millions of years, but only a tiny fraction of that time is spent using radio communication before moving to some other technology, the window during which we could detect each other might be vanishingly brief. We might be like someone trying to make a phone call to every house in a country, where each household's phone is only connected for an hour in the middle of one random night. The probability of both phones being operational simultaneously is extraordinarily small. Our radio technology itself defines what we can detect. We've built telescopes sensitive to certain frequencies, using specific techniques, limited by particular atmospheric effects and interference patterns. If civilizations elsewhere broadcast at frequencies we're not monitoring, or use modulation techniques we wouldn't recognize as artificial, or encode information in ways our analysis wouldn't detect, we might miss their transmissions entirely. We're looking for signals that resemble what we ourselves might send, which might or might not be universal. The big ear, when it detected the wow signal, was listening to only a narrow band of the radio spectrum. Think of the electromagnetic spectrum as a cosmic ocean of possible frequencies, and our radio telescopes as fishing with tiny nets in small patches of that ocean. We might catch something if it's there, but we're missing most of what might exist. Modern SETI has broader bandwidth, but we're still sampling, searching discrete portions of an effectively infinite parameter space of possible signals. Earth's own radio emissions provide another layer of context. For about a century, we've been inadvertently broadcasting our presence through television, radar, and radio communications. These signals spread outward at the speed of light, creating a slowly expanding bubble of artificial radio noise centered on our planet. This bubble is currently about 100 light-years in radius, meaning any civilization within that distance, if they're listening with sensitive enough telescopes, could already detect us. Beyond that distance, our signals haven't arrived yet. We're invisible to anyone farther away unless we send deliberate, powerful transmissions. This asymmetry is worth contemplating. If another civilization detected us through our leakage radiation and sent a response, we wouldn't receive it until twice the distance to them in light years had passed. If they're 50 light years away and detected us 20 years ago, their response wouldn't reach us for another 30 years. The communication delays imposed by the speed of light mean that any conversation across interstellar distances occurs in geological time from a human perspective. So when we think about the wow signal, we're thinking about a detection made from one small planet during a tiny slice of cosmic time, using technology that can only observe certain types of signals in a galaxy vast beyond human comprehension. The fact that we detected anything unusual at all is remarkable. The question isn't really, why haven't we found more signals like this, but rather, how did we get lucky enough to find even one? The wow! Signal exists within the context of a larger puzzle known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" This paradox, this tension between the apparent probability of a widespread life in the universe and the absence of evidence for it, provides a framework for thinking about what the wow signal might represent. The basic reasoning behind the Fermi Paradox goes like this. The universe is vast and old. Our galaxy alone contains hundreds of billions of stars, many with planets. The chemical elements necessary for life as we know it are common throughout the universe. The physical laws that govern the emergence of life on Earth apply everywhere. Given enough time and enough opportunities, life should arise in many places. Some fraction of those life-bearing worlds should develop intelligence. Some fraction of intelligent species should develop technology. Some might become spacefaring, capable of spreading to other star systems. Even without faster-than-light travel, a civilization could colonize the entire galaxy in just a few million years, a blink of an eye on cosmic timescales. And yet, we see no evidence of such colonization. We detect no artificial structures in space, no signs of massive engineering projects, no obviously artificial signals except possibly one ambiguous 72-second detection that might not even be artificial. The galaxy appears empty of other technological civilizations, or at least they're not making themselves obvious to us. This absence, this silence, is the paradox. Various solutions to the Fermi Paradox have been proposed, and the wow signal relates to several of them. One possibility is that technological civilizations are simply rare. Perhaps life emerges on only 1 in a billion suitable planets. Perhaps intelligence is an unlikely evolutionary outcome. Perhaps technology-using civilizations typically destroy themselves shortly after developing radio communication. If civilizations are rare enough in both space and time, we might expect to find weak, ambiguous evidence at best. Perhaps only occasional unexplained signals like the wow signal rather than clear, sustained contact. Another possibility is that civilizations exist, but don't broadcast or advertise their presence. Perhaps they've learned that announcing yourself to the cosmos is dangerous, that the first civilization to reveal itself might be the first to be discovered by something hostile. or perhaps they simply don't see the point in broadcasting to planets that might not have developed receivers yet. In this scenario, the wow signal might have been an accidental detection, our catching a glimpse of a transmission not meant for us, a fleeting exception to a general rule of cosmic silence. There's also the possibility that civilizations advance beyond radio technology so quickly that the window during which they can be detected electromagnetically is brief. They might move to other communication methods, laser pulses, gravitational wave manipulation, quantum entanglement, or technologies we can't even imagine. If most civilizations only use detectable radio for a few hundred years before moving on, and if we're just now entering our own radio era, the overlap probability is tiny. The wow signal might represent one of those rare moments when two civilizations' technological windows briefly aligned. Some solutions to the Fermi Paradox suggest that we're essentially alone, that Earth is genuinely unusual, that the emergence of complex life and intelligence requires such an unlikely combination of circumstances that it's happened only once in our galaxy's observable region. In this framework, the wow signal becomes even more mysterious because it doesn't fit. If we're alone, what created that signal? We're pushed back toward natural explanations, however incomplete they might seem. Then there's the possibility that life and civilization are common, but we're among the first. The universe is old, but heavy elements necessary for planets and life were scarce in the early universe. Perhaps the era of widespread life and intelligence is just beginning, and we're pioneers, early arrivals to a party that will become crowded in the coming billions of years. The wow signal, in this view, might be one of only a handful of other early civilizations, rare but not alone, separated by vast distances and gaps in time. Each of these frameworks for thinking about the Fermi Paradox changes how we interpret the wow signal. Is it an anomaly, a hint of commonness, an exception? Or a measurement error? The signal doesn't resolve the paradox. If anything, it makes it more acute. It's enough to suggest something might be there, but not enough to tell us what or why. It keeps the question open, the possibility alive, while providing no clear answers. Building on these thoughts about the Fermi Paradox, let's contemplate more deeply what the cosmic silence, broken only by ambiguous signals like the wow signal, might be telling us. Silence is information too, even if it's difficult to interpret. One interpretation of the silence is optimistic in a peculiar way. Perhaps civilizations that survive long-term learn restraint. They don't broadcast because they understand the risks, or because they've transcended the need for attention. They develop technologies that don't leak into space, or they communicate in ways we can't detect. They're there, potentially abundant, but we can't see them because they've learned subtlety. In this scenario, the wow signal might have been a mistake, a young civilization's brief broadcast before they learned caution, or a deliberately brief beacon meant to test for listeners without giving too much away. A more sobering interpretation is that the silence reflects a filter, some challenge or transition, that most or all civilizations fail to navigate successfully. Perhaps the development of technology inevitably leads to self-destruction through war, environmental collapse, or accidents. Perhaps there's something about becoming a spacefaring civilization that's extraordinarily difficult or dangerous. The silence could be a warning, a cosmic graveyard marker, evidence that intelligence tends towards self-destruction. If this is true, the wow signal becomes poignant, a brief voice from someone who existed once but might not anymore. There's also the possibility that the silence is simply evidence of distance and timing. Space is incomprehensibly vast. Even at the speed of light, signals take thousands of years to cross small fractions of the galaxy. If civilizations exist but are scattered thinly across space and time, the probability of our radio bubbles overlapping during the brief windows when both are using compatible technologies might be infinitesimal. We might be shouting into a void not because it's empty, but because everyone else is too far away or shouting at the wrong time. They're signals having passed by Earth before we existed or not yet arrived. The silence might also reflect our own ignorance about what to look for. We search for electromagnetic signals because that's what we understand, what we use, what our technology can detect. But the universe offers countless other possible communication channels. Neutrino beams, gravitational wave modulation, exotic particles we haven't discovered yet, or phenomena we can't even conceive of might carry messages that pass right through our detectors unnoticed. We're like someone listening for knock at the door while everyone else is texting. The silence we perceive might not be silence at all, just our inability to hear on the right frequencies or through the right media. Another possibility worth considering is that we're making assumptions about motivation that don't apply universally. We imagine that civilizations would want to communicate, would see value in contact, would broadcast greetings or information. But perhaps intelligence doesn't universally lead to curiosity about others. Perhaps most civilizations are content within their own systems, uninterested in the effort and risk of contact. Or perhaps they exist in forms so different from us that the concept of communication as we understand it simply doesn't apply. The silence could reflect not absence but fundamental difference. There's also what might be called the zoo hypothesis, the idea that advanced civilizations know about us but deliberately don't interfere or contact us, perhaps observing us like researchers watching an uncontacted tribe, waiting for us to reach some threshold of development before making themselves known. The silence, in this view, is intentional, respectful, or experimental. The wow signal might have been an accident, someone breaking protocol briefly, or a test to see if we're paying attention. Each of these interpretations of silence leads to different thoughts about the wow signal. If silence is learned caution, the signal was a momentary lapse. If it's evidence of a filter, the signal might be an echo from someone who didn't survive. If it's about distance and timing, the signal is a lucky coincidence that might never repeat. If it's our ignorance, the signal might be noise compared to what we're missing. If it's lack of motivation to communicate, the signal becomes even more anomalous and harder to explain. What all these interpretations share is uncertainty. The silence doesn't tell us which of these possibilities is correct. It doesn't resolve questions, it multiplies them. And the wow signal, sitting in the middle of all this silence, becomes more mysterious, not less, the more we think about what the absence of other signals might mean. Let's turn now to a gentler topic, the mathematics that underlie our hope for contact, and what the wow signal represents within those mathematical frameworks. This isn't about rigorous calculation, but about understanding the logical structure of optimism in the search for extraterrestrial intelligence. The Drake equation, formulated by Frank Drake in 1961, is an attempt to estimate the number of active communicative civilizations in our galaxy. It's not meant to produce a precise number, but to organize our thinking about the relevant factors. The equation multiplies together several terms: the rate of star formation, the fraction of stars with planets, the number of potentially habitable planets per star system, the fraction of those where life arises, the fraction where life becomes intelligent, the fraction that develop detectable technology, and the length of time such civilizations remain detectable. When Drake first proposed this equation, we knew almost none of these values. We could guess, speculate, hope, but we couldn't measure. Now, thanks to missions like Kepler and TESS, we know that planets are abundant. Most stars have them. Many are in potentially habitable zones where liquid water could exist. This knowledge has shifted the Drake equation's uncertainties. We've gone from wondering if planets exist to asking how many of them support life and intelligence. But the remaining terms in the equation, the biological and social ones, remain deeply uncertain. We have exactly one example of a planet with life, Earth. From this sample size of 1, we're trying to estimate universal probabilities. It's like trying to determine the average human height from measuring one person. The estimate might be wildly off and we have no way to know. The wow signal doesn't directly tell us these probabilities, but it provides a kind of boundary condition on the equations. If the signal was artificial, it suggests that at least one other technological civilization existed relatively nearby, and relatively recently in cosmic terms. This would constrain some of the Drake equation parameters, suggesting the product of all those fractions and factors is high enough that we could detect something in a few decades of searching. If the signal was natural, it tells us nothing about civilizations, but perhaps something about unusual astronomical phenomena we should look for. There's also what might be called the inverse problem. Given that we detected one anomalous signal in decades of searching, what does that imply about how common such signals are? This depends heavily on our observation strategy, the coverage of our searches, and assumptions about how often and how long civilizations broadcast. The mathematics are complex, but the basic logic is straightforward. If signals are very common, we should have detected more. If they're very rare, we might not have detected any. One ambiguous detection suggests something in between, but the error bars are enormous. Bayesian thinking provides another mathematical framework for thinking about the wow signal. Start with a prior probability that extraterrestrial civilizations exist and transmit detectable signals. When we observe the wow signal, we update this probability based on how likely the signal would be if civilizations exist versus if they don't. But the update depends on the signal's characteristics and our ability to rule out natural explanations. Since we can't definitively rule them out, the Bayesian update is modest. We should increase our credence in extraterrestrial civilizations existing slightly, but only slightly. The math tells us to remain uncertain. There's comfort in mathematics here, a kind of grounding. Instead of wild speculation, we can think in terms of probabilities and evidence and updating beliefs based on observations. The wow signal doesn't prove anything, but it shifts probabilities, however slightly. And continuing to search, continuing to observe, continuing to gather data, all contribute to a gradual refinement of our estimates, a slow accumulation of knowledge even in the absence of definitive detection. The mathematics also remind us that absence of evidence isn't evidence of absence, at least not strong evidence. We've searched a tiny fraction of the sky at a limited range of frequencies for a cosmically brief period of time. The fact that we haven't found abundant clear signals tells us something, but it doesn't tell us that no one is broadcasting. It might just tell us that our search is still in its infancy, that we need to look longer, more carefully, more comprehensively. And so the mathematics of hope are appropriately uncertain and incomplete. They give structure to our thinking, but not answers to our questions. Like the wow signal itself, they suggest possibilities without confirming them. They keep the question open while acknowledging how hard the question is. As we move deeper into our contemplation of the wow signal and what it might represent, we arrive at a more philosophical consideration. What does our potential cosmic loneliness mean for us as a species? And how does an ambiguous signal like this one affect our sense of place in the universe? There's a particular kind of loneliness in being potentially unique. If intelligence and civilization are rare cosmic accidents, if Earth is the only place in vast regions of space where minds have emerged to contemplate the universe, that places enormous weight on our continued existence. We become not just important to ourselves, but cosmically significant. Perhaps the only eyes through which this region of the universe has ever become aware of itself. The responsibility this implies is profound. Destroying ourselves wouldn't just be a human tragedy, it would be a cosmic one, the extinction of possibly the only awareness in billions of light years. The wow signal touches this loneliness because it suggests tantalizingly that we might not be alone, but then withholds confirmation. It's like hearing footsteps in an empty house, a momentary sense of presence that then vanishes, leaving you more aware of the silence than before. If we're searching for companions in the cosmos and finding only absence punctuated by ambiguous hints, that might be more isolating than never searching at all, never allowing ourselves to hope for contact. But there's another perspective, one that finds peace rather than distress in potential solitude. If we're alone, or if we're so isolated that we might as well be alone, then this universe is ours to explore, to study, to eventually spread through if we choose. There's no need to worry about conflicts with other civilizations, no fear of hostile encounters, no concern about violating cosmic norms we don't yet understand. Loneliness becomes freedom. Uniqueness becomes opportunity. The emotional relationship humans have with the idea of extraterrestrial intelligence is complex and contradictory. We want to find others because it would answer profound questions and ease our cosmic loneliness. But we're also perhaps a bit afraid of what contact might bring. History suggests that when civilizations with technological disparities meet, the results are often tragic for the less advanced one. If others exist, are vastly older than us, and detect us before we're ready, what might that mean for our future? The absence of signals could be protective, a shield of ignorance that keeps us safe from dangers we can't yet comprehend. The wow. Signal sits in this psychological space between hope and fear, between loneliness and relief. It's strong enough to suggest we might not be alone, but not strong enough to confirm it. It allows us to maintain both possibilities simultaneously. The universe might be full of life and intelligence, or it might be empty except for us. This ambiguity might be more comfortable than certainty in either direction would be. There's also a temporal dimension to cosmic loneliness worth considering. We might not be alone in space, but we might be profoundly alone in time. Civilizations might be common on cosmic timescales, but separated by millions or billions of years. We might be living in a galaxy where thousands of civilizations have risen and fallen, where thousands more will eventually arise, but where at this particular moment we're the only ones currently active and technological. This form of loneliness, isolation in time rather than space, is perhaps even more poignant because it suggests connections are possible but never realized. The act of searching, of listening for signals, of maintaining hope for contact, might be valuable independent of whether we ever find anything. It says something about us as a species that we're curious enough to search, hopeful enough to build telescopes and dedicate resources to listening, humble enough to acknowledge we might not be the universe's only intelligence. The search itself is a statement of values, curiosity over complacency, hope over despair, connection over isolation. And perhaps the wow, Signal's greatest contribution to our understanding of cosmic loneliness, isn't what it tells us about others, but what it reveals about ourselves. We care about this question. We want to know if we're alone. We're willing to devote time and thought and resources to finding out. This caring, this curiosity, this unwillingness to accept isolation without questioning it might be the most fundamentally human response to the cosmos we find ourselves in. As we contemplate the silence punctuated by one ambiguous signal, maybe what we're really contemplating is our own nature, our need for connection, our hopes and fears about what we might find or not find in the cosmic darkness. And that contemplation, that self-examination prompted by the search for others, might be valuable whether we ever find cosmic companions or not. We're entering the final portion of our journey together, and it's appropriate that we turn now toward acceptance, toward peace with what we know and don't know, toward finding meaning in the search itself rather than demanding answers from the universe. The wow! Signal, after all this exploration and contemplation, remains mysterious, and perhaps that's how it should be. There's a modern cultural pressure to solve everything, to find explanations, to leave no questions unanswered. We consume mystery novels where every clue leads to a satisfying conclusion. We watch detective shows where cases are resolved in an hour. We scroll through articles promising quote 16 about various topics. But the universe doesn't work according to narrative satisfaction. Some mysteries remain mysteries. Some questions don't have answers, or at least not answers we can currently access. Learning to live with this uncertainty, to be comfortable with the unknown while still engaging thoughtfully with it, is perhaps one of the most valuable skills we can develop. The wow. Signal has been teaching this lesson for nearly 50 years now. It refuses to be definitively explained. It resists our attempts to force it into clear categories. It remains, stubbornly, mysteriously, itself. A strong, narrow-band signal detected once and never again. Extraordinary enough to demand attention, but ambiguous enough to prevent conclusion. Scientists who've studied the signal have demonstrated various ways of living with this uncertainty. Some maintain hope that new evidence will emerge, that future observations or new theoretical frameworks might provide the explanation that's eluded us. This is active engagement with mystery, a refusal to give up while also refusing to claim premature understanding. Others have moved on to other questions, acknowledging that without new data, the wow signal has taught them what it can, and their energy is better spent on problems that might be more tractable. This is also legitimate. A recognition that intellectual resources are finite and must be allocated thoughtfully. But many people, scientists and non-scientists alike, simply hold the wow signal in their minds as an open question, a reminder that the universe contains genuine mysteries, that our knowledge has limits, that there are things we might never fully understand. This holding, this patient acceptance of not knowing, is its own form of wisdom. What makes a mystery worth living with? Worth keeping open rather than forcing closed with incomplete explanations? Perhaps it's when the mystery points towards something important, when the question it raises matters regardless of the specific answer. The wow signal raises profound questions. Are we alone? How would we know if we weren't? What would contact mean? These questions have value independent of whether the wow signal itself was artificial or natural. Thinking about them, wrestling with them, contemplating their implications, enriches our understanding of ourselves and our place in the cosmos. There's also value in mysteries that resist our usual categories and explanations, that force us to acknowledge the limits of our current understanding. The wow signal does this. It doesn't fit neatly into quote 17 or quote 18. It occupies an uncertain space between these categories, and that uncertainty is informative. It tells us that our classification systems might be incomplete, that the universe might contain phenomena that don't fit our expectations or our ability to categorize them cleanly. Living with mystery also requires a certain generosity toward others who might interpret the same evidence differently. One person might lean toward the signal being natural, another toward it possibly being artificial, and both might be doing so reasonably based on the same evidence. Acknowledging this possibility, respecting different interpretations while maintaining one's own uncertainty, is increasingly rare. The wow signal invites us to practice this tolerance for ambiguity, this acceptance that smart, well-informed people might reach different tentative conclusions from incomplete data. And perhaps most importantly, living with the mystery of the wow signal teaches us that the search for truth is valuable even when truth remains elusive. We've learned enormous amounts thinking about this signal, about radio astronomy, about statistics, about cosmic probabilities, about ourselves. We've developed technologies, refined methodologies, asked better questions. The mystery has been productive, generative, valuable, even without resolution. As we move toward the end of our time together tonight, this lesson about living with mystery feels right. Not every story ends with all questions answered. Not every search concludes with discovery. Sometimes the search itself, the thinking and wondering and careful investigation, is what matters. The wow signal has given us nearly 50 years of productive uncertainty. That's not a failure of understanding. That's a gift of enduring fascination, a question that keeps giving us reasons to think, to search, to wonder. As we contemplate the future of the search that the wow signal represents, let's think gently about what might come next, what new technologies and approaches might finally resolve the mystery, or perhaps deepen it further. The future of SETI and radio astronomy offers both hope and realism, both exciting possibilities and sober acknowledgement of continued challenges. Modern radio telescopes are immensely more powerful than the Big Ear was in 1977. Facilities like the Very Large Array, the Arecibo telescope before its collapse, the Green Bank telescope, and newer installations around the world can detect far fainter signals across much broader bandwidths. If something like the wow signal occurred today, we'd capture more data at higher resolution with better ability to rule out interference and characterize the source. This improved capability means that future searches have a better chance of not just detecting anomalies, but understanding them. The Square Kilometre Array, currently under construction in Australia and South Africa, will eventually be the most sensitive radio telescope ever built. Its collecting area will be, as the name suggests, roughly a square kilometre of antenna surface. This enormous facility will be able to detect signals far weaker than anything we've been able to see before, and it will survey vast swathes of sky continuously. If civilizations are broadcasting, if signals like the wow signal are out there waiting to be found, the SKA might find them. Machine learning and artificial intelligence are also changing how we search. Traditional SETI has relied on humans to define what an interesting signal looks like, to set parameters for automated searches, to review potential detections. But machine learning can find patterns in data that humans might miss, can identify anomalies based on subtle characteristics rather than explicit rules. These technologies might discover that the wow signal has companions in our archives, other moments of strange data that weren't quite strong enough or didn't quite fit the search parameters to be flagged at the time. There's also growing interest in searching for optical signals, laser pulses that might be deliberately sent by civilizations as beacons or communication attempts. These would be harder for us to detect accidentally, since optical searches require looking at specific targets during observation windows. But they might be more efficient for civilizations trying to communicate across interstellar distances. Expanding beyond radio to optical and other parts of the electromagnetic spectrum increases our chances of detecting something. The Breakthrough Listen project, funded by private donations, represents a new model for SETI. Well-funded, comprehensive, systematic. It's conducting the deepest and broadest search ever undertaken, observing millions of stars across wide frequency ranges, analysing enormous amounts of data with sophisticated algorithms. If signals are moderately common and detectable, Breakthrough Listen has a reasonable chance of finding them within the next few decades. But we should also be realistic about timescales and probabilities. Even with improved technology, the universe is vast and the number of possible signals to search for is essentially infinite. We might build telescopes 1,000 times more sensitive and still find nothing. Not because nothing is there, but because the probability of looking in the right direction at the right time at the right frequency remains low. The search might continue for centuries before producing another candidate as intriguing as the wow signal. There's also the possibility that new theoretical understanding will provide retrospective insight into the wow signal. Perhaps we'll discover a type of natural astronomical phenomenon that produces brief, narrow band bursts under specific conditions, and we'll recognise that the wow signal fits this category. Or perhaps our understanding of how civilizations might communicate will evolve, and we'll realise we've been interpreting the signal incorrectly. That it contains information or structure we didn't initially recognise. The archive of the wow signal itself might yield new insights. As analytical techniques improve, as we develop new ways to squeeze information from limited data, researchers might return to those same numbers and letters that Jerry Ehman circled and discover details that weren't apparent before. The signal was recorded at relatively low resolution by 1970 standards. We can't go back and observe it again, but we can continue to analyse what we have in new ways. Whatever the future brings, the search will continue. There are too many people fascinated by the question, too much invested in the search, too much genuine scientific value in the effort. The wow signal might never be definitively explained, but it will continue to inspire searches to motivate new technologies, to remind us that the cosmos holds mysteries worth investigating. As our journey together draws closer to its end, let's contemplate something that might seem contradictory: the genuine beauty that exists in not knowing, in uncertainty, in questions that remain open. The wow signal, in refusing to be definitively explained, offers us something precious that a clear answer might not: space for wonder. There's a certain magic in mysteries. When we encounter something we can't fully explain, it invites imagination, contemplation, the entertaining of possibilities. If the wow signal had been immediately and obviously identified as a known natural phenomenon or a satellite transmission, it would have become a footnote, a brief moment of excitement that resolved into mundane reality. But because it remains unexplained, it continues to provoke thought, to inspire wonder, to keep alive the question of whether we might not be alone. This doesn't mean we should prefer ignorance to knowledge. Scientific understanding is valuable, truth is worth seeking, and resolving mysteries advances human knowledge in important ways. But there's also value in living in a universe that still contains genuine unknowns, that hasn't given up all its secrets, that remains mysterious and surprising. The wow signal is one of a small number of phenomena that legitimately resist our attempts at complete understanding, and there's something almost poetic about that resistance. The uncertainty also keeps us humble. We're clever as a species. We've figured out extraordinary things about the universe. We've made predictions that observations have confirmed with remarkable precision. But we don't know everything. We can't explain everything. The wow signal stands as a gentle reminder of our limitations, of the gaps in our understanding, of the possibility that the universe might be stranger than we currently imagine. This humility is valuable. It guards against arrogance, against assuming we've figured out all the important things, against closing our minds to possibilities that don't fit our current frameworks. There's also beauty in the very fact that we care about this mystery, that we've devoted decades to thinking about it, searching for explanations, contemplating its implications. This caring says something profound about human nature. We're not content with immediate practical concerns. We ask deeper questions. Are we alone? What was that signal? What might it mean? These questions don't necessarily help us survive, don't put food on tables or cure diseases, but we pursue them anyway because we're curious, because we want to understand, because the mystery itself is compelling. The conversations, the wow signal has sparked over the years have value independent of whether we ever definitively explain it. Scientists have developed new theories, refined search strategies, built better instruments. The public has engaged with questions about life and intelligence and cosmic isolation. Students have been inspired to study astronomy and physics and computer science. All of this happened because of a mystery, because of something we didn't understand and couldn't easily explain. The uncertainty has been generative, productive, valuable. And there's a peculiar kind of companionship in shared mystery. All of us who've thought about the wow signal, who've wondered what it was, who've contemplated its implications, are connected by this shared question. We don't need to agree on the answer. We don't even need to believe there will be an answer, to be united by the question itself. The mystery creates community, brings together people who might otherwise have nothing in common except their curiosity about this unexplained event. Perhaps what's most beautiful about the uncertainty surrounding the wow signal is how it holds space for hope. As long as we don't know definitively what it was, we can imagine it might have been a message, a greeting, evidence of others looking out into the cosmos just as we are. This hope might be unwarranted, it might be contradicted by eventual explanation, but for now, in this moment of not knowing, it's alive and real. And that hope itself has value. It makes the universe feel less empty, less lonely, more full of possibility. So as we think about the wow, signal's enduring mystery, perhaps we can find peace not despite the uncertainty, but because of it. The universe has given us a genuine puzzle, something that resists easy answers, something that keeps drawing us back to fundamental questions about our place in the cosmos. That's a gift, even if it's not the gift we thought we wanted. It's the gift of genuine wonder, of earned humility, of productive uncertainty, of hope that remains alive precisely because it hasn't been definitively contradicted. And that, in its own way, is beautiful. We're approaching the end of our time together, and it feels right to think about what comes after this conversation, what continues beyond the wow, signal and our contemplation of it. The search for extraterrestrial intelligence continues, our exploration of the universe continues, our questioning and wondering continue. These things go on independent of whether any single mystery is ever resolved. The astronomers and scientists who search for signals haven't stopped because the wow signal wasn't repeated. If anything, that non-repetition has informed their methods, taught them about what to look for and how to look for it. Every night, telescopes around the world point at the sky, collecting data, listening to the radio whispers of the cosmos. Most of what they hear is natural. Pulsars spinning, galaxies emitting, the background hum of the universe itself. But they keep listening, keep searching, keep hoping that someday another signal like the wow signal will appear. And this time we'll be ready to confirm it, to understand it, to know definitively what we're detecting. Your own journey with this question doesn't have to end either. You can look up at the night sky, at the stars scattered across the darkness, and know that we're actively searching for signs of life among those points of light. You can follow news of new discoveries, new technologies, new searches. You can think about the questions we've explored tonight. What would it mean to find others? How would it change us? What does the silence tell us? These questions don't require professional training to contemplate. They're human questions, profound and accessible, worthy of thought from anyone who looks up and wonders. There's also value in sharing these questions with others, in talking about the wow, signal and what it represents, in keeping alive the sense of wonder and curiosity that the search for extraterrestrial intelligence embodies. When you tell someone about this mystery, about a signal detected nearly 50 years ago that no one can definitively explain, you're passing on not just a story, but an invitation to wonder, to question, to imagine possibilities beyond our everyday experience. The tools for engaging with these questions are increasingly accessible. Data from SETI projects is available online. You can join distributed computing projects that analyze radio telescope data using your computer's spare processing power. You can read scientific papers, follow researchers on social media, watch lectures and documentaries. The search for extraterrestrial intelligence, once the exclusive domain of professional astronomers, has become something anyone can participate in, or at least follow along with interest and understanding. And even if you choose not to actively engage with the search, simply knowing that it's happening, that humans are collectively listening to the cosmos, searching for signs of others, has its own value. It's a reminder that we're capable of asking big questions, of pursuing knowledge that doesn't have immediate practical application, of working together on projects that span decades and might not succeed in our lifetimes. The search for extraterrestrial intelligence is, in this sense, one of humanity's more noble endeavours, an expression of curiosity and hope and willingness to invest in understanding rather than just survival. The wow signal story isn't over either. As long as it remains unexplained, researchers will return to it, will analyse it with new techniques, will compare it to new detections, will think about it in the context of evolving theories about the universe and life and intelligence. The signal exists as data, preserved, available for examination by future generations who might have tools and insights we don't yet possess. Perhaps someone reading this now, or someone who will be born decades from now, will be the one who finally figures out what it was. Or perhaps it will remain mysterious indefinitely, a question that outlives everyone currently thinking about it. What continues, certainly, is the fundamental human impulse that led to the search in the first place. The desire to know, the refusal to accept that we're definitively alone without at least asking the question, the hope that the universe might be more interesting, more populated, more connected than it appears. This impulse has driven science for centuries. It's driven exploration, discovery, the expansion of human knowledge across every domain. The search for extraterrestrial intelligence is just one expression of this fundamental human characteristic. And so, our journey doesn't really end. It pauses. We've spent time together thinking about the wow signal, exploring its mysteries, contemplating its implications. But the signal itself continues to exist as data, as mystery, as invitation to wonder. The search continues. The questions remain open, and that's appropriate. Some journeys don't have endings, just moments of rest before continuing onward. In these final moments of our exploration together, let's gather up what we've learned, what we've felt, what we might carry forward from this contemplation of the wow, signal and all it represents. Not answers necessarily, but perhaps better questions, deeper understanding, more nuanced appreciation for mystery and uncertainty, and the human drive to search for truth even when truth remains elusive. We carry forward an understanding that the universe is vast beyond human comprehension, filled with phenomena we don't fully understand, containing possibilities we can barely imagine. The wow signal is one tiny piece of this vast puzzle, one moment when something unusual occurred and we happened to be listening. That we detected it at all is remarkable. That we can't fully explain it reminds us how much we still have to learn. We carry forward appreciation for the scientists, volunteers, dreamers and searchers who dedicate themselves to questions that might not be answered in their lifetimes. Jerry Ehman circling those 6 characters on a printout, astronomers maintaining observation programs that might never find anything, engineers building more sensitive telescopes, analysts developing better search algorithms, all of these people working on a problem that offers no guaranteed returns, only the possibility of profound discovery. Their dedication is worth honouring and remembering. We carry forward the knowledge that absence of evidence is not, in fact, evidence of absence, at least not strong evidence. We've searched a tiny fraction of the sky for a cosmically brief period, with limited technology. The fact that we haven't found abundant clear signals might simply mean the universe is vast and we've barely begun to search it properly. Patience, persistence, and continued improvement in our methods and tools are what the search requires, not despair at apparent silence. We carry forward the understanding that uncertainty can be acceptable, even valuable. We don't have to force explanations for everything immediately. We can sit with questions, contemplate possibilities, remain open to new evidence while acknowledging what we currently don't know. The wow signal has taught this lesson for nearly 50 years now. It's okay not to know. It's okay to wonder. We carry forward a sense of our cosmic context, our position as one small planet orbiting one ordinary star in one galaxy among billions. We're not the centre of the universe. We might not even be particularly special or unique. But we're here, we're aware, we're capable of asking questions about our place in the cosmos and actively searching for answers. That capacity for curiosity and systematic investigation is itself remarkable, worth celebrating regardless of what we discover or fail to discover. We carry forward hope, tempered but real. Hope that we might not be alone, that somewhere in the vast darkness between stars there might be others asking the same questions, wondering if anyone else is out there. Hoping for contact. The wow signal, whatever its source, keeps this hope alive. It's evidence that we might detect something, that the search isn't necessarily futile, that answers might exist even if we haven't found them yet. We carry forward questions that matter. What is intelligence? How does it arise? How common might it be? What would contact mean? How should we think about our responsibilities as possibly the only technological civilization in our region of space? These questions have value independent of whether we ever detect another signal or make contact with another civilization. They push us to think more deeply about ourselves, our nature, our future, our relationship with the cosmos we inhabit. And perhaps most importantly, we carry forward a sense of wonder. The universe is strange and beautiful and mysterious. It contains phenomena like the wow, signal that resist our attempts at explanation. It's vast enough that our searches have barely scratched its surface. It's old enough that civilizations might have risen and fallen countless times before we ever existed. It operates according to physical laws we've discovered, but might contain surprises we haven't yet imagined. This wonder, this sense that the cosmos is endlessly fascinating and worthy of study and contemplation, is perhaps the greatest gift the wow signal offers us. As we prepare to part ways, as your breathing slows and your thoughts quiet and sleep begins to approach, you can hold these things gently in your mind. The universe is vast. We've barely begun to explore it. One signal, detected once nearly 50 years ago, remains unexplained, and that's okay. It's beautiful even. It's a reminder that there's still mystery, still wonder, still reason to keep searching, keep questioning, keep looking up at the stars with curiosity and hope. Thank you for staying with me through this entire journey. We've travelled together for 2.5 hours now, from that August night in 1977, when Jerry Ehman circled 6 characters on a printout, through decades of searching and speculation, to this quiet moment of reflection and peace. The fact that you've listened this long means something. It means you care about these questions too. It means you're willing to sit with uncertainty and mystery. That's a rare and valuable quality. From the Big Ear Radio Observatory detecting something it couldn't explain, to the modern telescope still searching that same patch of Sagittarius, to the scientists and dreamers who keep the search for extraterrestrial intelligence alive, we've explored not just a signal but a question, not just data but meaning. And the answer, as honestly as I can give it, is that we still don't know what the wow signal was. Perhaps we never will. But in the searching, in the thinking, in the wondering, we've touched something profound about human nature and our relationship with the cosmos. What we've learned suggests that the universe is vast and strange, that our knowledge has limits, that mysteries remain worth contemplating even when they resist solution. The wow signal might have been artificial or natural, a message from across the stars or an anomaly in our own detection systems, evidence of others or evidence of how much we still have to learn about the universe. Each possibility leads to its own form of wonder. If you enjoyed this slow drift through cosmic mystery, I'd be grateful if you'd leave a like and let me know in the comments what you think about the wow signal. Do you believe it was natural or possibly artificial? What do you find most fascinating about this enduring mystery? And to those already subscribed, thank you for being here, for sharing these journeys into the unknown with me. Your support makes this work possible. Wherever you are in the world right now, in whatever quiet corner you found to end your day, I hope this time together has brought you some peace. I hope your breathing has slowed, that your thoughts have settled, that your body feels heavy and warm and ready for sleep. I hope the questions we've explored together don't keep you awake, but rather provide gentle company as you drift off, reminders that the universe is vast and beautiful, and full of mysteries we're only beginning to unravel. Look up at the stars if you can imagine them, wherever you are. All those points of light, hundreds of billions of suns, each perhaps with their own planets, their own stories. Somewhere out there maybe, someone else is looking up at their sky, wondering if anyone else exists, hoping for a signal. And for 72 seconds on one August night nearly 50 years ago, maybe we heard each other. Dream of signals received and sent, of messages crossing the cosmic void, of the moment when loneliness ends and connection begins. Dream of telescopes listening patiently to the whispers of space, of scientists analysing data with hope and careful skepticism, of the universe revealing its secrets slowly in its own time. Sleep well. Rest in the knowledge that the search continues, that the questions remain open, that tomorrow the telescopes will listen again to the cosmos, patient and hopeful. Good night,